Motion and time. We are taking question answers on that. The first is classify the following as motion along a straight line. This is straight line, circular, or oscillatory. So motion of your hand is oscillatory. Motion of horse pulling a cart on a straight road is straight motion. Motion of a child in a merry-go-round is circular. Motion of a child on a seesaw. Seesaw is like this. It goes like this. The movement is like this. So it's oscillatory. Motion of the hammer of an electric bell. This is, we'll see. And motion of a train on a straight bridge. So this is straightforward. Motion of a train on a straight bridge is straight. So oscillatory, straight, circular, oscillatory, and the motion of the hammer of an electric bell is oscillatory motion. And of course, the straight bridge, train moving, is straight line motion. Which of the following are not correct? The basic unit of time is second. So this is correct. Every object moves with a constant speed. No. If you are in a hurry, you will walk faster or you will run. So this is not correct. Distances between two cities are measured in kilometers. Yes. The time period of a given pendulum is not constant. This is not correct. It has to be constant. That is why you will have a constant time. A speed of a train is expressed in meter per hour. No. It should be kilometer per hour. A simple pendulum takes 32 seconds. This is the time being given to complete 20 oscillations. So these are the number of oscillations. Let me write it NOS. What is the time period of the pendulum? So time period is equal to total time divided by the number of oscillation. As in the question given that total time is 32 and number of oscillation are 20, divide them, we'll get 1.6. So this will be 1.6 seconds. The distance between two stations is 240 kilometers. A train takes 4 hours to cover this distance. Calculate the speed of the train. Now one formula you have to remember always, for later classes also, later exams also. So speed is equal to distance upon time. This is very important. So speed equal to distance by time. Distance is 240 kilometer and train is 4 hours. So it will be 240 by 4 and 460. So it will be 60 kilometer an hour. An odometer. Odometer deals with the speed computation calculation. So the odometer of a car reads this much when the clock shows time 8:30 am. What is the distance moved by the car if at 8:50 am the odometer shows this reading? So this 8:30 and 8:50, that means 20 minutes have elapsed, and this is the distance, the difference of these two distance or these two readings are the distance being traveled. So we have to calculate the speed of the car in kilometer per minute. This is very important. We have to change the unit also. Express the speed in kilometer per hour. So again we have to change the unit into kilometer an hour. So speed equal to distance by time, that we'll be using directly. But what is the distance? Distance is the difference between the higher one and lower one, because this is the distance traveled. Say if you are here in say at 2 kilometer mark, and in 20 minutes you move 4 kilometer. So 4 minus 2 is the 2 kilometer distance you have traveled. Similarly, the logic will apply here. So we'll take the difference. This is the distance you have traveled. Now 8:30 to 8:50, that means 20 minutes. So you can have 20 minutes. You can change it into hours. So you know that in 1 hour there are 60 minutes. So you have to divide 20 by 60. That way you get 20 by 60, 1 by 3 hour. So speed equal to distance by time, 50 kilometer and 20 minute, which we have computed because we want it in kilometer per minute. But when we want it in hour, kilometer per hour, so the time taken we are going to use 1 by 3 hour instead of 20 minutes. So 15 by 1 by 3, 3 goes up, 15 into 3 is 45 kilometer an hour. Salma takes 15 minutes her house to school on a bicycle. Speed of her cycle is 2 meter per second. we have to calculate the distance between her house and the school. So here the speed is 2 meter per second, and we know that in 15 minutes, in 1 hour we have 60 minutes, and in 1 minute there are 60 seconds. So in order to change the minute into second, we have to multiply this 15 by 15 to 60. So we get 900. And so the distance, of course, speed equal to distance by time. So distance will be speed into time. So speed into time, speed is this much, time is this much, multiply 1800 meter. So that will be, if you divide it by 1000, you get it in kilometer, because in 1 kilometer there are 1000 meters. So 1.8 kilometer is the answer. Show the shape of the distance time graph for the motion of the following cases. So a car moving with the constant speed. So constant speed is like this. The distance, with time, the distance traveled. So constantly. And a car parked on the roadside, that means it is not moving. So the speed will be constant with time. So this is the actual graph. This is a car moving with constant speed. So this is the time, this is the distance. This is constant. And because with time there is no change in the distance, so it remains constant. So there will be a straight line. Which of the following relation is correct? As I suggested you earlier, speed equal to distance by time. So this has to be correct. Second is the correct one. Others are not fulfilling the criteria. The basic unit of speed is its meter per second. A car moves with a speed of 40 km an hour for 50 minutes, and then with a speed of 60 km an hour for the next 15 minutes. So the total distance covered by car. So for first distance d1, it travels for 15 minutes 40 km an hour. Then this d2 distance 60 km an hour, 15 minutes again. So we'll compute d1 and d2 and then we'll add them. So speed equal to distance by time. You know the distance will be speed into time. In the first case, we'll multiply these two and then we'll multiply these two and then add. So in the first case, this is 40 km an hour, but the time is in minutes, so we need to change it into hour. So we'll divide 15 by 60, because we know in 1 hour there are 60 minutes. So we have to divide it. So 15 by 60. Then we will multiply speed into time, as I suggested you here. So it will be 40 into 15 by 60, that will be 10 km. For the second part, the speed is 60 km an hour, 15 minute, we'll change it to 15 by 60 hour. Multiply them, you get 15 km. We have to add these two. This will be 25 km. Suppose the two photographs, which are shown here, has been taken at an interval of 10 seconds. So the interval is 10 seconds, that is the time is given to us, it is 10 seconds. If a distance of 100 meter is shown by 1 centimeter. So because the marking is given, so from here to here this is 2 centimeter. So 2 centimeter, 1 centimeter is 100 meter. So 2 centimeter will be 2 into 100, that is 200 meter. Calculate the speed. So speed equal to distance by time. What we are going to do here is the distance covered as I suggested, because this is 2 centimeter. So it will be 2 into 100, 200 meter. Time taken is already given 10 seconds. Speed is distance by time. So 200 by 10, that is 20 meter per second. This figure shows the distance time graph for the motion of two vehicles A and B, which one of them is moving faster. See, for this particular time, say this time, if you match it with the distance traveled by A is more than the distance traveled by B. That is why A is moving faster. So vehicle A is traveling longer distance in less time as compared to B. So vehicle A is moving faster. Which of the following distance time graph shows a truck moving with a speed which is not constant? So here the truck is standing, here it has a constant speed, and here we have the thing. That means this is not a straight line, that means it shows a truck moving with a speed which is not constant.